Let's start off with the most basic of points, the one at the origin, when x and y are both 0. Now, just to get you oriented on this graph, we're going to make each tick mark equal to pi over 2 units. So this is pi over 2, pi, 3 pi over 2, and 2 pi. And then in this direction we have negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. But this point right here, that's the origin. So I'm going to make a chart here. 3 columns. All right? I'm going to have an x column, a y column, and a dy dx column. All right? So this point right here is the coordinates 0, 0. So what I'm going to do is I'm going to plug these coordinates into the differential equation and get a result. So I'm going to plug in 0 for all the x's I see, and there's only that one right there. And I'm going to plug in 0 for all the y's that I see. But there are no y's here. So I don't have to plug in a 0 for a y. Now just quickly, right, in this case when I get to the origin, yeah, I'm going to have to plug in a 0 for this x and a 0 for this y. This is a Diffie Q that has both x and y. This Diffie Q right here only has x, so it's going to make our lives a little bit easier. All right, so we're going to plug in 0 for x, so we have the cosine of 0. All right, now according to our knowledge, what is the cosine of 0? Yes, it's equal to 1. So what we're going to do here is we're going to make a short line segment at this point, which has a slope of 1. So there we go. Okay. Let's move to another point. Let's go to the point right above it. This is the point over 0 up 1. All right, that means I'm going to plug in 0 for x and 1 for y. But there is no y, so it doesn't really matter what's going on here. I'm going to plug in 0 for x again, so I have the cosine of 0, which is still 1. So at this point, I'm also going to draw a slope of 1. And in fact, it doesn't really matter what the y value is. I'm going to go up one more point, right there, over 0 up 2. dy dx, replace x with 0, so I have the cosine of 0, so once again, the derivative is equal to 1. So for this entire axis, I'm going to have a slope of 1. Okay. Now, let's move to another point. Let's go to this one right here. That's the point over pi over 2 and up 0. So x is pi over 2 and y is 0. So the derivative means I'm going to plug pi over 2 in for this x. So I have the cosine of pi over 2. Cosine of pi over 2, remember that from your knowledge? Yeah, cosine of pi over 2 is 0. So I'm going to have a little line segment with slope 0 at that point. Let's go up one value, pi over 2 and up 1, that spot right there. Again, the y is inconsequential here because there is no y to plug in. So I'm going to plug in pi over 2 for x again, so I get the same value, cosine of pi over 2, which is 0. So just like in the previous column, every single slope is going to be the same. Now we get to the cosine of pi. So we're going to go over pi and up 0. Again, this column doesn't matter for plugging in. All we have to do is plug in pi for x. Cosine of x. Well, cosine, actually, now it's cosine of pi. Cosine of pi is negative 1. So we're going to have a negative 1 slope here. And in fact, we're going to have it everywhere. All right. So what I invite you to do now is pause the video and see if you can recall what the value of cosine of 3 pi over 2 is, cosine of 2 pi, and then determine the cosine of the opposite of pi over 2, the opposite of pi, the opposite of 3 pi over 2, and the opposite of 2 pi. I'm going to pause the video as well. I'm going to fill it in as you're working on it, and when you come back, we'll compare our slope fields. Okay, we're back, and hopefully you had a chance to fill out your slope field. We see that at pi over 2, we already knew that the dy dx, the derivative was 0. At pi, the derivative was negative 1. At 3 pi over 2, the derivative is back to being 0. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is 1, so we have 1 slopes right here. And then over on this table, again, the y value doesn't really matter at all. At negative pi over 2, the cosine of negative pi over 2 is 0. The cosine of negative pi is negative 1. The cosine of negative 3 pi over 2 is 0. And the cosine of negative 2 pi is 1. Right, so this is what the slope field hopefully looks like for you. Right? Now, what I'd like you to do, if you have your calculator, or you can just take a look at mine, again, look at the slope field, and then take a look at the calculator. Right? Notice how the calculator has positive slope on the y-axis, and then zero slope, and then negative slope, and then zero slope. Positive slope, zero slope, negative slope, zero slope. Just like what we see here. But remember, right here, this is all of our sine functions. Over here, we created this, but we didn't use sine at all. We used cosine. We used the derivative to create the general solution. Now, that's the idea behind a slope field. Okay, you're still coming up with the answer. The answer is sine x plus c. This is the graph. It's segments of the graph of sine x plus c. We created this graph using the derivative. We didn't use this at all because sometimes we cannot antiderive cosine x, whatever that function happens to be. We can't antiderive it easily, but we can use this differential equation to create the slope field, and the slope field will be the same thing as the general solution. Okay, because again, what you see here, we can mirror right there. And if you don't quite see it, that's okay. Take a pen and pick a spot. All right, let's pick that spot right there. So let's expand this line. All right, so we're going up in this direction, and there we go. We're expanding. Come on, pen, work. There we go. All right, but as soon as we get here, we have to kind of level off because all the slopes here are zero. All right, so now we're level. But then as soon as we get to this vertical column right here, now all of our slopes need to be negative. Right? And then when we get to this column right here, our slope needs to be zero again, so we have to level off. And then positive. All right, so then we have the same thing happening right here. All right, when we got to level off. All right, and then we have that positive slope again. Take a look at this curve and notice how it matches with this orange curve right here. Okay, so the slope field is making the exact same thing. That's the idea behind the slope field. Quickly look at our key points. All right, the slope field can be quickly created. Some might argue about that word. All right, but created from the Diffie-Q. All right, and the slope field represents the general solution to the Diffie-Q. One more time. This right here is the same as that right there. Okay, we talked about key point number 3 about how to make the slope field. And again, to get a particular solution, you just need an initial condition. This curve that I drew right here, this is a particular solution because we worked off of that initial condition. The curve has to go through the point over 0, up 1.